Hello, everyone, and welcome again. My name is Ahmed Abdul Wahab. I'm working with Omicron Bahrain Middle East, and today we are going to see how we can test the transformer differential protection relay from Siemens Dixie 5 using the Omicron PTL. So as you can see, we open already Dixie 5 project. It's a transformer differential, two-winding transformer, and the device we name it as Omicron Bahrain. So the first step we have to do is to confirm the relay settings is correct, and we can go to the transformer differential protection 87T, and you will see the function is active and everything should be okay. So the function is on, and this is our relay settings, and we have to the operating slope is 30% for slope 1, and for slope 2 is 70%. In section 1 is 0.67, in section 2 is 2.5. Then we have the iDiff fast, it's on, and we have the I differential unrestrained. This is the function we will make it on, and with 6 I rated. For the time being, we don't want to test the iDiff fast, we will make it off, and we will save the project. Then I will just go to the device, I will load the configuration, and I will just type the password, which is 6 times 2. Now I should send the setting to the relay, establishing the connection. And as you can see, now we are writing the configuration to the device. For the time being, till I send the setting to the relay, I will show you the Test Universe 4.3. We recommend to download it from our website, the latest version of Test Universe 4.3. Here from the test document, we will open the PTL protection library. Then we will go to Siemens. And from Siemens, we will pick the transformer differential, the latest one, 7UT86 version 7.8. What's the difference between this one and the earlier version? As you know, that Dixie 5 was not supporting, didn't support exporting of the relay parameter in X-ray format for the version before 7.8. So also we recommend you to update your Dixie to have the benefit of exporting the relay setting in X-ray format, as we will see later. Now, once I open the folder, you will see 3 files. The first file is the OCC file. The second is a X-ray file. The third is the manual. The OCC file is Omicron Control Center, and it is released, by the way, in September 2021. And the other file is the X-ray converter. Here, the X-ray converter, as the people know who is working mainly with Omicron, that we have some kind of scripting and equation written in the OCC file, and all equations and the scripting already here in the X-ray converter. That's important to import the relay setting and to draw the relay characteristic. So for the people who is familiar with our scripting, they can change some equation, they can change some parameter. So what we recommend is you can change everything here in the X-ray converter, and later on you can import it to the OCC file to maintain the test module what Omicron make it for you, and later on you can add your module as you want. Then I will just open the the OCC file, and you can see now the relay is already written to the setting already written to the software. Now I'm opening the test document. Let me drag it to this screen here, as you can see. So the second step, now I will go here, go to File Project. Either you can export or import from here, but you need to highlight the device, or you can go from here very easy way. You can go to export. Once you open the export, you will see the X-ray setting of single device for use in testing equipment Omicron. You will just press export. Then it's already written. Let me save it in somewhere else. Then I will go to PC and I will look at C folder work. Then I will go to, for example, webinar. Let's say I will save it here, and I will just give the name of 30. Then I will export, and yes. Now I'm exporting the device, and you can see it is successfully exported. Then I will press OK. And from the OCC file, I will just press the test object 7UT86. Then I will go File, Import Relay Settings. Then I need to use the standard filter of X-ray. Then press OK. Then I will go to the C folder, Work, Webinars, KPI improvement. Then I will import it, and you will see that it's already imported 57 parameter. This is the first the basic step, or the first step. But as we know that the 7UT relay can support 2-winding transformer and 3-winding transformer. This is, I can make it here in the additional information, transformer information. As per my configuration, it is 2-side transformer. I need to make it here 2-side. This is another important setting you need to do it. The second one is the relay information. You should know your relay type. Is it fast or high speed or a standard relay? So our relay is fast, and this is, you can get it from the short name of the device. This is important because based on this, the tolerance of the time will be changed between the standard relay or the fast relay or the high speed relay with semiconductor transistors. So our relay is a fast relay. Then I will press OK. After that, I don't need some functions which is already available here in the OCC file, but it is not active in the relay itself. Then I will press the delete inactive module. Then it will delete all modules which I don't want and which is already not active. Now everything is done, and I deleted. Based on our Ohm's law, Omicron Ohm's law, now we define the object, which is the transformer differential protection. The hardware configuration here, I need to connect side 1, side 2 transformer, and I need to have trip 1, trip 2, trip 3, which is 3-side transformer. If you have 2 sides transformer, the third one is not active, and you can see the asterisk, and the binary input number 5 is a backup. This is important to know, and important to connect your CMC as per this wiring, because the configuration in the OCC file depends on this connection diagram or the hardware configuration. Another thing is, and it's important also, you need to understand, or you need to know exactly what are the feedback from the relay to the CMC. Is it dry or wet? Dry, it means that you are using a contact with no voltage on it across the binary output, or you are using wet contact. Wet contact, it means there is a voltage once the binary input is closed, so it will pass a voltage, and this voltage will be fed to the CMC. This is, you can adjust it here in the binary and the analog inputs. So you can, if you tick it, it means that it is wet. If you tick the binary input, it means it is dry, which is potential free. If you untick, it means it is wet. So I'm going to use my scheme here, which is wet, with a voltage rated of 24 voltage. The second one here is 24 voltage as well. The third one also is 24, and the backup is also 24. Now I can just press apply and OK. Once you enter the nominal range of the voltage is 24, you will see it is multiplied by 70%. This is for the threshold, so the binary input will not consider the contact is closed if the voltage fed from the relay to the CMC is less than 17 volt. Then I will press OK. Once again, I can start directly, and as we can see, if I press start continue, automatically this message will pop out, and it will tell you you need to read the relay manual, the 7UTX relay manual from Siemens, and you need also to read the PTT or the PDF file, which is available in the same folder where you open the OCC file from our PTL. Once you press continue, it will give you another message, tells you that you need to verify that the measured value as per the injected. Then I will press continue. And once it is start injecting, so it is injecting restraint current equal 1 and differential current should be 0 because the fault is external outside the protected zone. Then I will see here that the differential current is 0 and the restraint current is 1. Then I need to press pass. Automatically the current will return to 0, and it should open another module to test the feedback from the relay is fine and the trip time is as per the relay setting, which is around 28 milliseconds. As you can see, it's very fast. Now I need to do the first important test, which is the diff configuration or stability against the external fault secondary. So I will simulate three different cases: fault at side 1, fault at side 2, phase to phase, phase to ground, and fault at side 1, fault at side 2, 3 phase. Then I will press continue, and you will see that it is injecting here one fault. The fault is in the primary side and the supply is in the secondary side, single phase to ground, and you can see here the differential current equal to 0 and the restraint current is 0.66, 0.33, 0.33. This is mean it is stable. Then I will press pass. Now it will open the second module, which is the ABC fault, and I should have restraint current equal 1 and differential current equal 0, which is correctly. Then I will press pass. After that, it will open another module, but the other side, the fault will be in the secondary, supply will be in the primary, and it is the same case, single phase fault. Here in the web browser, you will see that the fault is stable. Then I will press pass. Then three phase fault on the secondary, supply in the primary. Then you will see here in the edge, now in the web browser, that the differential current is 0, the restraint current is 1. Then I will press pass. This is the important test, and it is, we can say, the primary test, differential or stability against differential, stability against external fault. Now we are going to test the inrush harmonic and second harmonic. As we know that in the case of the inrush, if we have the fault here, so it means the harmonic content is less than the setting, so it means it is not an inrush current, it is a fault, because our limit is the harmonic percentage is 20%. In this area, the characteristic will the relay should trip, and then the current, which higher harmonic 20%, it means that the fault, it is an inrush current, not a fault. Now we are testing the pickup. Everything you can see, it's automatic, calculated automatic. Now the pickup from the other side, pass. Now we are going to test slope. As you can see here, we are testing slope 1 and slope 2. But why there is two different colors? Because the characteristic of the combined characteristic. Some of the relay, they have something we call it combined characteristic and no combined characteristic. It means that if you have a fault in the phase A and this fault can trip the other two phases, like in RET 670. But in Siemens, no combined characteristic is active. So based on that, we did some kind of a calculation to avoid the tripping of the other two phases, the healthy phases. So you can have, this is a clear on, and it is the real characteristic of single phase fault. You can see it works very fine, and the slope as per the relay setting. Now we are testing at 3.5. Now we are searching the slope, and you can see it is done. Now we are testing the BC. The BC fault, the no combined characteristic and the combined characteristic has no effect on that, because phase-to-phase fault, it doesn't respond to the combined characteristic. So you will see it's two slopes, and which is the real slope 30% and 70%. So we test in the slope 0 or in the flat area. Now we are testing in slope 2, which is slope 1, which is 30%. Now we test in the breakpoint between the two characteristics. So now we are testing at 3.5. You can see everything is automatic. Now we are testing at 4.5. That's good. We finish phase to phase. Now we are testing three phase. Same three phase. The combined characteristic has no effect on the three phase. So what we are going to do is, just for the time's sake, let us do something different. I will just stop here and go back. Then I can just go to the view and I will press just I want to see the report view. And the report view, you will see that everything you tested, it's already here. But it is a table. If you would like to see the complete characteristic, what you will do is you will go to home, the report, use the long form, and automatically the report will include everything. The relay settings will include the table will include also the graph. So now it is adapting the relay characteristic, and it is adapting, sorry, the report itself. As you can see, initial test, every test with a name, so it gives you the real parameter and the injected current and also the result. So you don't need to waste your time in the manual way of filling your test report, because it will be automatically filled. Now it is updating the diff and pickup, side 1, now side 2, now the characteristic, single phase, phase to phase, now three phase. Now it's applying the configuration of the report. As you can see, it takes no time to adjust the report to have everything. You can customize the report from the report setting, whatever you would like to see. You can see all the wave, the signal diagram, the time diagram, the assessment, and also the table of the relay settings. You can see here. Now let us see something. For example, here I need, this is the trip, this is the pickup and drop off. Now this is the characteristic here for the single phase. You can see it is clearly from the single phase, 5 out of point tested, 5 point pass. Now what else I can do? I can just go here to A-N, and if I want to add another ramps, then I would like to test this area of the unrestrained, so I will choose at 11, so it will give me search line at 11. Then I will choose as 12 to confirm the unrestrained differential. Then I will press OK. So it is testing now the first search line. So you can customize the testing term, you can customize the testing file as you want. You can also change the fault type from L1 to L2, or you can copy paste and then change the L2 from L1 to L2. And also you can change here the general. You can just do some more settings if you would like to. Now we are testing at 2.5. Now 3.5. You can hear the ticking from the relay itself, so it means it's injecting. And here from this active signal. Now we are testing at 4.5. here at the end of the slope number 2 and just before the unrestrained characteristic, and it should give me the value here exactly within the tolerance. Now we are testing at 12. It should be on the flat side, so it means the unrestrained value is 6 I rated. I hope you enjoyed this short video, and stay tuned for more upcoming videos. Thank you. My name is Ahmed Abdul Wahab, and I hope to see you again. Goodbye.